Hello, everyone. Thank you so much for joining this session. My name is Karan, and today I'll be talking about using the Chaos Toolkit to determine the resiliency for your web app. So, before I begin the presentation, I would like to thank the entire team of the Python WebConf 2022 for giving me this opportunity to present my talk. So, thank you so much. So here's a brief background about me. So I have been working primarily as an mobile Android mobile application developer for the past 5+ years now. I've been working primarily on developing B2C and B2P based applications. I've also been working on cutting edge technologies like AI, AR, and VR. And more recently, I've been also involved in certain projects involving DevOps. So, and I would say, apart from being passionate about technology, I also love writing poems, traveling to different places across the globe, and meeting new people. So, that's about me in a nutshell. Now, they say failures can actually cause expensive outages to companies. And a lot of software companies, are using microservices and cloud-based architectures nowadays to create their end solutions and products, and no longer are the systems, I would say, simple systems where you had either a single front end or a single back end. But nowadays systems are more heterogeneous in nature and are getting complicated day by day. And to be honest, nowadays there is even no time for a downtime. So then the question arises, how does actually one try to deal with failures, especially failures in case of production environment? So for that we need to understand something called as chaos engineering. Now, chaos engineering, if if you have to define it, it means it helps to identify weaknesses in a system through certain controlled experiments, to introduce certain random or unpredictable behavior. Now, this phenomena, this concept actually came, into existence and became very much popular, especially after the Netflix story, which involved the development of a tool called Chaos Monkey. And this tool basically would was used to disable randomly some production instances to identify again the failures without impacting the end user. So as developers, we all want our systems or our end products to be robust, right? So and hence there is a need for us to plan, or to identify failure as early as possible. And one needs to identify these weaknesses through controlled experiments, and for that actually one needs to have a kind of a toolkit. So for that, we have something called as the Chaos Toolkit. Now, the Chaos Toolkit is a simple engineering toolkit made for developers. It is based on Python and it has mainly two objectives. So one objective is to again to apply the principles of chaos engineering. So it provides an easy starting point for developers to apply these principles of chaos engineering. And on the other hand, it also provides an open API to integrate with multiple systems. So these are the primarily the two main objectives. Yes, it is open source and it can also can be extended to any system as well. And the highlight of this kind of a toolkit is that it allows developers to define their experiments using standard JSON or YAML. So one need not actually try to learn any particular specific language for this. Using this toolkit, one can easily rely on JSON or a YAML, his JSON or a YAML knowledge to basically start creating or start writing his first chaos experiment. So how does actually one go about writing your first experiment? So for that, you need to install Chaos Toolkit. So Chaos Toolkit, by the way, it officially supports Python 3.6 and above. And one can actually install it using a simple pip command, where you could run the pip command to install the latest version. By creating, you could create a virtual environment and then install that, in that as well. So this is how easy it is to get started or to install Chaos Toolkit. But before we try to first create an experiment, it is important for us to understand a concept called the steady state hypothesis. Now, what exactly is the steady state? So steady state, if you had to explain it to a normal person, it would be basically a normal state, a state in which your system is working perfectly fine. So a steady state hypothesis mainly involves two things. So before you run the experiment, you need to ensure that your system is in the normal state or it's working as expected. And as well as once your experiment is running, or once it has run successfully and finished, Then two, you need to basically check whether your system is still in the steady state or in the normal state. So the steady state hypothesis basically involves comparing the system in case of two scenarios before the running of the experiment and then after running of the experiment as well. So this is how important this steady state hypothesis is. So we will understand this when we write our first experiment. So let's try to understand how an experiment looks. So this is an example, a very simple example of how a simple experiment can be defined. So here you can see I have an experiment.json file which contains a title, a description, and I have my steady state hypothesis block which is defined. It also contains something called as probes. Now, probes are basically a way of observing a set of conditions of the system which is under experimentation. So one could actually define a probe. In this case, I have defined a probe which has a tolerance of say 200. So this is basically tolerance. Basically, would mean that it would expect this value, to or it expect the status as 200, especially when I'm using a provider, in this case as an HTTP provider. So the idea here is to basically hit the endpoint and to check if everything is up and running. So this is how one could actually define his steady state. But then it all depends on the requirement of the project as well, where the steady state hypothesis can mean different for different projects as well. In addition, you see something called as a method block. So a method block basically it represents the set of activities that you would need to carry out as a part of the experiment, and it would contain, again, you could define certain actions and probes as a part of the method block. Actions would basically represent those activities, and there's also a block which is called as rollbacks. So rollbacks basically would, as the name suggests, would help you to roll back to revert any particular action that you may invoke as a part of the method block. So this is a very simple example, or a very basic example of how one can actually write his first an experiment with a steady state hypothesis. It is important to note that the steady state hypothesis here is something which is mandatory, so you need to define a steady state hypothesis in your experiment. So that is about how one can write his first experiment. So coming to the next part, where how does actually run it, how does one actually run it? So to run it, you use a simple command which is basically chaos run followed by the name of your experiment file. So in this case, it is experiment.json. So what would happen is that the chaos toolkit will of course first validate your file. It will check if everything is correct syntactically. The file, if it file looks valid, it would then start running the experiment. And then as you can see, it starts checking for the steady state hypothesis. So this is going to run as a first step. It will check if the website is running, and if yes, it would say that the steady state hypothesis is met. And then is where it starts executing the methods and the various the actions that you have defined as a part of your probes or your methods block. So this is how it runs, and once it has executed that, it would again basically run the steady state hypothesis, or it will execute the steady state hypothesis to check if everything is fine as well. So this is how the experiment flows. So let's try to understand this using an example that I have come up with. So let's move to the editor now. So in this case, if I go back to my editor, in this case I have seen an experiment.json file which I have already created, which basically has the same kind of data. So in this case, I have defined the title of the experiment. I have defined the description of the experiment, and you can see something called as the contributions. Now the contributions are basically the valuable system properties. So in this case, I have defined certain properties of the target system which I want to check in terms of the reliability, the scalability. So here you can have certain values that you can define. So you can either have a low or a medium or a high, and if you don't want any kind of a value, you can also default it to say a none. So this is one of the additional properties as well that you can define as a part of your experiment. Now coming to the steady state hypothesis, where you see that I have a steady state hypothesis defined over here. I have a probe. I have a probes property in which I have the probe defined, and it has a tolerance of 200, and it has a provider of HTTP, which would mean that it would try to invoke this particular URL and it check if the status code is 200. If yes, it would basically it would mark this experiment, or it would understand that the experiment is okay. And if there is a tolerance which is not 200, or even like a different value, it would consider the experiment to be a failure. So this is this is why the tolerance value is important for you to determine whether the experiment is actually failing or whether the experiment has successfully executed or not. So one can actually configure this provider using multiple options as well. So maybe for this example, I will not deep dive much into that, but then one can actually create it, using based on his or her requirement as well. Coming to the next block, which talks about the method. So I mentioned the method block can contain a set of activities. So it can define a set of activities and which can be either of type probe or it can also be of type action. Now in this case, I have basically checked for a response. So I'm checking if my response, so I have a tolerance defined, which is of type JSON path, which means that I would, in the response, I'm checking for a variable called name, and I'm expecting the value to be the one that I have defined as a part of the expectation. So this kind of a tolerance or this kind of a configuration helps me to check to certain response parameters as a part of the the response that I get from the endpoint. And then the provider basically have the same kind of information, but in this case, I would point to a different, say, an endpoint that I would like to test as well. So this is how easy it is to to configure your certain actions and certain probes. Now coming to the part which is called as controls. So I'll be talking about controls in some time. So I will be discussing more on this. So coming to the next block, which is about rollback. So rollbacks, as the name suggests, would be basically to roll back or to undo a particular action. So here you could actually do a kind of a rollback where you can check if if there is an issue or something, you could roll back to the stage to the either to the steady state or to a state which is similar to the steady state. So that is basically how one could actually define a rollback. Now, how do we run this experiment? For that, let's see this in action. So for that, let me try to first run the server. So I would basically invoke the or run the server before running the experiment. So the server is up, and let's try to now run the experiment over here. So to run the experiment, you will use a chaos run command. So I have used the chaos run command followed by the experiment name. So let's see this. Let's try to run this. So as you can see, it will first start validating the experiment. If it's valid, it would go ahead and then it would start, running the steady state hypothesis. So here, as you can see that once the steady state hypothesis has been determined or has been met, it will start, executing the methods. And in this case, I have a probe already defined, which is basically to check if the website or the site or the endpoint returns 200 response. So this is how one can configure the various methods or the various actions as a part of your as a part of your experiment. So this is how one can go about creating a very simple experiment. So coming back to the presentation, so we talked about the running of the experiment. Now we need to understand how does one actually configure the chaos toolkit. Now, in terms of configuring the chaos toolkit for a Flask-based app, we need to also understand there are certain steps that we need to follow. So this is kind of a checklist that I would like to recommend that if you're trying it out for a Flask-based app, this is kind of a checklist that one could follow to ensure or to configure chaos toolkit in your Flask based app. So what one could do first is to define certain endpoints, and that is the I would say the first step. Second step involves using of a kiosk middleware. So I'll be talking about what exactly is a kiosk middleware. The third would involve creating control extensions, which also I'll be highlighting. And the last part is about automating the whole process. So of course you need to automate the whole process for you to basically ensure that there is no manual kind of an intervention. So you need to define these experiments and then run them automatically each time a certain kind of failures happen. So this kind of automation is critical as well to the overall process. So the first step basically is to define the endpoints. Now the endpoints is something that you would already have or you might have already be already have defined in your Flask based app. So here is where you could leverage that. So in this case, I have defined a couple of, I would say, certain endpoints which I would like to use for. So an endpoint which is returning maybe an okay response, an endpoint which is returning a failure response. So this is something that you could have already defined in your Flask app. And using this, one needs to define this so that one can actually check each one of these endpoints through the various methods, or through the various actions as a part of your experiment. So once you have defined the endpoints, and once you're aware of the various endpoints, you could then go on to the next step, which is basically to introduce something called as a kiosk middleware. Now, before we try to understand what exactly the chaos middleware, let's also try to understand why do we need to use a chaos middleware. Now, especially in web applications, or especially in applications that use microservices, you need to have something that would help you to allow or introduce certain failure conditions. And you need also something that would help to verify the application's resilience, in case of a failure as well. So for that, the good part is that there is a package that is already existing, which is called as a proof of chaos middleware Flask package, which is supporting Python 3.5 and above. And this package basically helps you to easily introduce failure conditions, or introduce certain concepts like delay and faults, as well simulation of delays and faults, through by configuring a middleware, a chaos middleware. So all you need to do is that you need to configure certain parameters like the application name, the application environment, and a token. And that is all that you need to basically introduce this kind of a chaos middleware in your Flask based app. So of course you will also need to install this as a part of your as a part of your the app itself. So you need to install this package. And once that is done, you can actually test it out by invoking one of your endpoints. So here is where I have tried it out using a sample endpoint that I had defined in my Flask app, where you can see that I have passed a header basically called as a xproof doc attack, which takes a particular value. And if I basically pass that, it would help me to introduce a failure in case of, or I would say simulate a failure or a fault condition. So this kind of a approach can help you to also identify what would happen in case of a failure, whether the endpoint is responding, or I would say behaving as as what is expected. So this is also one of the ways by which you could simulate faults and delays using the proof of framework and the extension that is provided. So moving on to the next slide. Now, we talked about using chaos middleware, but again, if you want to customize something, you would need to have something called as a control extension. Now, controls, as the name suggests, they're used to control or change the experiment, or the behavior of the experiment during the execution. And what the control extension offers is that it helps you to define a set of functions which are basically more of lifecycle methods, I would say, where you can actually leverage these methods to write your custom logic, where, like, for example, you have methods like the before activity control or the after activity control, or even like a configure control, where you could write certain custom logic to introduce certain change or unpredictable behavior. And the important part is that you need to declare it as a part of the experiment. So that is where the controls block would be leveraged. And you could define something like a provider in a property called provider within the controls block of the type Python, and then this specify the name of your model. So we will try to understand this in more detail through a demo as well. So after you activate the control extension, you will see that there is a slight change in the output in this case. So once you run the experiment in this case, you would see that once the website returns a 500 error, you can also log in a particular message, or you could do certain custom actions saying that, okay, yes, the website has returned 500. So there is something wrong, and that needs to be checked. So here is where you could write that particular message, or write that particular logic to as a part of the lifecycle method of the control extension as well. And this will help you, or help the developers understand that this particular endpoint is not as resilient as expected. So let's see this in action again through the editor itself. So here is an experiment that I have defined having a control extension. So this is the control extension which I have already defined. And if I can show you the extension itself, so you can see it as a part of the the packages that I have. So I have this JSON response kind of a simple, basically a control extension. So it has basically a control.py file which has all the lifecycle methods defined. So you have all the lifecycle methods defined over here, and one can write his custom logic over here itself. So in this case, I have gone with the simple logic where I have checked the output of the JSON. And in case of a proof doc kind of an extension, one can actually also use the same. So in case of proof doc, you will also see a control.py file. And once you open the control.py file, you can see that there are similar methods which you can check. So here is where you can actually write your own custom logic as a part of the methods to define to understand the behavior of the method, and also to try to make the developers aware like there is something wrong with the method itself. So this is a simple example of how one can configure. So let's try to run this experiment as well. So to run this experiment, let's use the same command that we used before. So this command would I would try to run it in say a verbose mode. So this will help you to understand the different steps that have been taken while running the experiment. So once I run this experiment, you can see that it has executed the experiment. So it has already met the steady state hypothesis has been called, and here is where the error was introduced. So if you see the message that was printed above, this was basically true to the proof doc, the attack that I had introduced as a part of my control extension. So once it has returned a failure, so yes, it has returned a failure, and this is where I have used the proved of extension to introduce that to purposefully introduce that failure. And once it has also reached the step where it has checked for the JSON response, in this case it has also succeeded, saying that yes, it has a response that it has returned 200. So this is how one can actually use the chaos toolkit to define control extensions, and also to customize those extensions for based on the project requirement as well. So this is about the control extensions. Now moving back again to the presentation. So coming to the last part, where once you have configured your extensions, it is important for you to automate now the overall process. And for this, one can leverage Docker with a Python image. So all you need to do is you need to create a Docker file which specifying the Python version, the virtual environment creation, and you could copy the requirements.txt file, run that, and then run the server on Docker itself. So that is pretty straightforward. But the main part is using something called as Jenkins, where this would basically do the whole I would say the whole pipeline thing, where you could actually create something called as a staged pipeline, and you can define your stages like building, that would involve building the Docker image, then running the container, which would in turn run the server, and then finally running your experiments as a part of that. So this three steps or three stages would help ensure that all your experiments which are there would run, and that would basically help you to ensure how resilient the system is, especially as a part of your pipeline. So the output of this would look something like this, where you could do a simple check of the environment. You could then build the Docker image, run the Docker container, and then finally run the chaos experiments itself. So this is the one of the ways, but you could use any kind of a CI framework out there to to automate this process as well. So coming to the end of the presentation, I would say yes, system failures have now become difficult to predict, and definitely there is a need for us to be proactive in our efforts to learn from failure. The focus should be now on creating a more resilient environment that allows to introduce failures as early as possible, and so that we can rectify them and avoid them in future. And the advantage, I would say, of using the Chaos Toolkit is that developers can also extend it using Python. So I mentioned about how one can create custom modules in order to basically achieve a particular functionality. So with this thought in mind, I thought to put down the link which I've mentioned below to download the slides and the sample code, which can be leveraged by other developers to to create, I would say, much better innovative solutions. So, so with that, I would once again like to thank the entire team of the Python WebConf again for giving me this opportunity. If you have any questions, please feel free to get in touch with me via email, and I would be happy to help in all cases. So once again, thank you, and have a nice day.